All right, so just a quick recap about the difference between lines, line segments, and rays. A line is something that goes on forever. It has no end. So that is going to have the two arrows on the end of it. So that right there, that is a line. Whereas a line segment doesn't have the arrows. It has two stopping points, where the line segment starts and where the line segment finishes. And then a ray has a starting point, and then it goes on forever with the arrow on the end. It doesn't matter which direction the ray points. We can have a ray that points in any direction. Although for notation purposes, if we were to write a ray, so if this is A and this is B, we would write AB with the little ray symbol on top, much that a line segment would be segment AB if we have points A, points B on there. And this line would have at least 2 points, AB. So it would have this symbol for the line on top. So lines, line segments, and rays, but of course, I mean, they all pretty much look the same, and we're going to treat them the same in terms of doing calculations. So these are line segments, which again have definitive stopping points. We can't calculate the distance of a line because it's infinite. But here, these measurements are finite. So if I have this line segment, and this is line segment ln, I can see that the whole distance ln is equal to 4, and this segment mn is equal to 2.6. So how much is the line segment LM equal to? Well, we can see that the whole line segment is ln, and that's made up of these two pieces. So ln must be equal to segment lm from here to here plus segment mn from here to here. So if ln is equal to 4, I have 4 is equal to lm plus 2.6, since mn is 2.6. Now this is just a simple equation to solve. If I subtract 2.6 from both sides, I get that lm is equal to 1.4. And since we're talking about centimeters, it's going to be 1.4 centimeters. And that's my answer. Over here, we have these fractions, and really I guess this is more of a fraction problem, but we can see that we want to find the length here of segment xy. Well, xy is equal to segment we want to find segment xz, and that's the sum of segment xy plus segment yz. So xz, the entire segment, is equal to 4 5/8 inches plus 2 1/2 inches. For us, it's going to be helpful to change these into improper fractions. So in order to change this mixed number, 4 5/8, to an improper fraction, we multiply the 4 and the 8 to get 32, and then add the 5, a nice little circular motion. So this is going to be 37 over 8. And 2 1/2, if we do the same maneuver, 2 times 2 is 4, plus 1 is 5. Now when I add fractions, I need a common denominator. So that's going to be 8, because 8 and 2 both go into 8. So I need to multiply this 5/2 by 4. If I do that, I get 20 over 8. So that means that segment xz is equal to 57 over 8. If I can reduce the fraction, I will. And there's no need to change this to a mixed number. For me, I prefer improper fractions, and you should get comfortable with improper fractions. So while some of you may see this as great, there's no need to do any extra work, hopefully everybody can appreciate that you should leave these as improper fractions. Just now that I look at this, don't forget to include your units. So these are in inches, so we can put inches as well. And this is doing segment addition. Now here we have a line, but we don't have the entire length of the line. We just have part of it. Basically this segment UT, this segment TS, and the total segment US. So we want to find the measurements of all of these. Well, we can see off to the side here that US is 45. And we know that UT is 5x minus 3, and TS is 7x. So that means that UT plus TS is equal to segment US. So UT is 5x minus 3, TS is 7x, and US is what we're looking for. And now we have this nice equation. So we have to find this out. Actually, sorry, US is not what we're looking for. US is 45. We need to find x. Now we have this nice equation we need to solve. So we're going to add 3 to both sides and combine these like terms. So 5x and 7x becomes 12x. When we add 45 and 3, we get 48. When we divide both sides by 12, we get that x is equal to 4. Knowing that x is equal to 4, we can see that UT is going to be 5 times 4 minus 3, which will be 17. TS will be 7 times 4, which will be 28. And of course, 45 is 45. So when we have situations like this with algebraic expressions, we need to set up an equation and solve for the variable and plug that value back into the expression representing the length of the segment. Just a real quick note about congruence. We will be working on this in class, but it is important to know what congruence means. This is the symbol. It's an equal sign with a tilde on top, a little toupee. And so congruence shows that 2 lengths are equal to each other. So for example here, if I say that segment XY is congruent to segment XZ, if I drew a line segment just like this, I could say that given these points, I'm going to do the best I can here, if this is X, Y, and Z, that means that this distance here, XY, is congruent to this distance here, XZ. Now on this actual line segment, you can see that I actually drew these little tick marks, and we'll use this when we look at diagrams. These little marks mean that the distance is congruent, but they're the same length. So for example, if XZ is 5 inches, and XY is 5 inches, and XZ is 5 inches, we can see that they're the same, they're equal. Congruence is just equal, but it talks about distances. It talks about measurements. So in previous classes, we could say that x is equal to 7, and that's true. X equals 7. That's the value of x. But congruent is a specific type of equal. It's equals when we're talking about measurement and distances. So that's the notes here for this lesson. So what we're going to do is we're going to get some practice with this. But as long as you know how to add certain segment lengths together and find variables, then you're set for this section.